So these are the sections we're going to talk about today. So there's one more loop I haven't talked to you about, and it's the do-while loop. And we're going to talk more about constructors, and we're going to do some random stuff. Alright? So, if you remember your UML diagram, we were doing the question, and the answer was yes, you do something, and then you go ask the question again, right? The answer is no, you just continue down the program. That was the while loop. Right? The if statement simply is the arrow going back to continue. Now, there's another type of loop that you might know about, is this. You do the code first, and then you ask the question. If the answer is yes, you do that code again. If the answer is no, you just keep going down. So that means this code is always executed at least once. So the while loop, we ask first, right? So this is a pre-test. And this we ask the question later. So the idea is we have to execute the code at least once, and an example we're going to use today is, for instance, you are playing blackjack or something. You at least draw a pair of cards, right? Then you see if you busted or not. But at least you draw the first one, always. You don't first see if you busted before you have any cards. And then you keep pulling cards until you think you're going to win, right? Or you bust. So that will be a good example of the post-test loop. When you're dealing with files, you first want to see if the file exists. You want to first see if the file has something to read. It could be a file that exists, but it could be empty. So you want to see if there are bytes to read. So that's a pre-test. You don't do this when you're reading files. Make sense? Alright. So the syntax, similar. We put do and then the while here. And we always use the curly brackets to delimit where it begins and where it ends. And then you ask the questions here. So the condition is here for your logical test. And here is where you put your end of statement. If you remember here, you do it like this. I don't think I need this. In here, you do it like this. You do while, and then you ask the question, right? Here's the condition. Notice that this one has a semicolon at the end, but this one doesn't. I mean, nothing happens if you do this at the end of the loop. Well, guess what happens if you put the semicolon here? It's gonna, the semicolon means ends of statement, right? So guess what? It's gonna say while the condition, end of statement. Now it's stuck in an if then loop there. It will never get to this because it terminated the statement there. So here we could write it, or we don't. It's optional. But in here we do need to have it. It's pretty simple. It's pretty straightforward. I think with the for loops and the while loops, you're pretty good. Let's do one real quick. I'm not gonna write it in the computer, but can I erase this? All right. You have any questions? We're good? Let's do a timer. How will we do a timer? We're going to do a timer with a while loop and a timer with a for loop for now. Alright? So a timer is like when you set your microwave. I mean, the first Java used to be called Oak, and it was for microwaves anyways. And fridges and appliances. So what I need, a couple of variables. I need minutes and seconds. Right. And tell me what to write. I want to do a timer that is going to display something like this. I'm gonna have the, I won't worry about the formatting right now. Like if it's single digits, I'm not gonna worry about putting 2 zeros for now. When in reality you will. So it will be minutes plus seconds. Oops, plus seconds. So this is what I have to print every iteration. Whatever the user entered, I mean, don't worry about what the user entered. We'll assume it started at 5 minutes, right? Want to count from 5 minutes all the way to 0, 0. So tell me, or help me fill out the blanks here. What's the first thing you will do? I'm sorry, what?
How many seconds are there? 60 seconds.
Okay, so will you declare it? I mean, it's a good idea to have constants. I mean, I wouldn't hard code it, but for the sake of the example, I'm not going to be so detailed. Well, let's say he has the user, right? So the user enter, I'm doing popcorn, right? I want minutes to be 5, and I want seconds to be 30. So I put 5.5 minutes. That's a big bag of popcorn in the microwave. All right, so how would I make it to go down to 0, 0? Don't worry about actually pausing for a second each time. I'll show you that later when we do graphics.
Could write if seconds is greater than 0 minus 1.
I'm sorry. What do I write here? Tell me what to write.
Would you write 1 minute equals 60 seconds?
I mean, you can write that. That's a constant, or you can just hard code it. That's fine. Yeah.
Would you
do like a while loop for
Okay,
if
so-
seconds are greater than 0, then increment 1 down. Like,
Okay, so I got a while, and what do I write in this while here? What does it go inside?
seconds greater than 0.
You want seconds to be greater than 0. Okay,
And curly brackets. Second minus the minus.
you want to write seconds minus here?
Yeah.
Okay. You're not so far off, but help him.
Which would be like an and if units are greater than 0.
So you want me to do an and here? And minutes greater than 0.
Then we just have to like declare 1 second, which is 0, when it comes off.
Okay, yeah, you do, but how do you tell the computer to do that?
Would that be part of the else?
Those while loops have else?
Part of the escape clause?
Okay.
Is that what?
Alright, so the way it is right now, I count 29 times down. And then when seconds hits 1, it decrements 1, it prints 0, 0. And then 0 greater than 0, no. So it exits out, right? So minutes stay at 5. So when actually the way the code reads right now went down 29 times. So that's not what we want, right? So what happens when seconds get 0? What would you like to do?
Minus 1 for the minutes.
Okay, and what happens to the seconds?
Reset to 60.
Okay,
What was your original? 59.
so how would you write that? So what I'm getting at here is you need 2 while loops, right? One for the seconds, one for the minutes. You have an outer and an inner loop. And so you need 2 while loops. So the body of this while loop is another loop. So which one do you think is going to execute more times, the outer or the inner loop?
The inner.
The inner loop, right? And so which one should execute more times, the minutes or the seconds?
Second.
So the second should be in the inner loop. So we're gonna write here while seconds is greater or equal than 0 actually. And what would you write here? Well, it's the same thing, right? Minutes is greater or equal than 0. Alright, so I got my conditions. Like that is an infinite loop right now, right? So what do I need to write in order to fix this? Man, by the time you tell me the movie is over, I don't need the popcorn anymore.
Would you do that seconds minus maybe?
Where?
What the seconds? The loss.
Like here?
No.
Here? Alright, so if you look at your microwave and you want to 5.5 minutes and you press 5:30, you want the 30 to show up? Or you want it to 29 to start?
20.
Actually, you see the 30. Yeah, so it should be here. I display the 30, then I discount 29. What happens when it gets to 0? 0 is greater or equal than 0, yeah. I display the seconds. Now seconds is minus 1, right? It's minus 1 less greater or equal than 0, no. So I go here. So what does it go in here? What do I write here?
Minutes minus 1 and seconds equals 60 minus 1.
You put seconds equals what?
No, you can't do that. You have to reset it back to 60 or 59.
You want to reset it back to 59, right? Because it'll be weird if your microwave says 40, 60, right?
Yeah.
So that now is correct. What will happen if I print this here? What will that print? A green line. How much you want to bet? So what will this line print? Look at the code.
Will it print 5 minutes and 30 seconds because it's not inside the curly bracket?
No, this is outside the curly bracket. This is that, and this is this. Really? 459? I want you to follow the logic, not just guess. Look at the code.
It's in the while loop. If minutes is not 0, it's going to turn back to the while loop, right?
Yeah, but the green is not inside the while loop. So what this green print?
Oh, 5 minutes and 30 seconds.
That's what it will print.
It's not the while loop.
Does the while loop execute there? If it starts at 5:30, will this execute?
Yes.
Okay. So when it's done executing, what will be the values of minutes and seconds?
0.
No. Follow the code.
-1?
Okay, and
-1.
will be -1, -1? No. So let's assume I have 1 minute, 1 second, right? So minutes is 1, seconds and 1, right? So is 1 greater than 0? Yeah. Displays 1 minute and 1 second, right? Decrement seconds to 0, right? Is seconds 0 greater or equal than 0? Yeah. So I display 1 minute and 0 seconds. I decrement seconds. What's the value of seconds now? -1. Is -1 greater or equal than 0? No. Exits the loop, right? Now what happens to the minutes? So now it's 0. What happens to the seconds? Okay, so I go up now. Is 0 or greater or equal than 0? Yeah. And then it goes here. What's the value of seconds right now? 59 greater or equal than 0? Yeah. Right. So execute this 60 times. Now I'm at 0 minutes and 1 second. 1 greater or equal than 0? Yeah. Display 0, column 1. Decrement seconds. Now seconds is 0 greater or equal than 0? The answer is yes. So it displays 0, column 0. What happens to the seconds? -1, right? Go back. Is -1 greater than 0? No. Exit. So what was the value of minutes? So now what's the value of minutes? A decrement.
-1.
Decrement -1, right? What happens to seconds? 59. Go up. Is -1 greater or equal than 0? No. What does it print? -1 and 59. Right? That's when the bell rings. Right? Does it make sense? Alright, because if you don't go line by line and look at the code, if you're trying to intuitively guess the answer, it's not going to work. Because the computer doesn't know what you mean. The computer does what you tell it to do. Questions? Alright. So now you know how to do a timer. If you do it in the computer here, if you write this in a program, it's going to print all the way down from 530 to 00, right? But it'll happen in less than a second. So there's a way to do it. It's called using threads, and we'll talk about timers later. I don't want to confuse you. So it seems really simple when I do it, right? Well, questions?
How would we get it to stop at 0?
Well,
Which is
if let's say if the minutes is, if I only put 30 seconds because I want a quick heating. Oh, let's do 3 seconds. Right? So the computer executes top to bottom. Looks at this. Minutes, which is 0. Greater or equal than 0? Yeah. So it goes inside the loop, right? The computer doesn't know it's inside a loop. It's looking at this line. It doesn't know what the previous line was. Right? Seconds greater or equal than 3 equal greater or equal than 0? Yeah. Displays 0 and 3, right? Now seconds is 2. Right? It hits this curly bracket. This curly bracket is matching this curly bracket, right? So it goes back to the matching curly bracket. Right? It's 2 greater or equal than 0. So it displays 0, column 2. Seconds decrease to 1. So now seconds is 1. It's the curly bracket, so it goes back to the matching curly bracket. 1 greater or equal than 0. At this point, it doesn't remember it's inside another while loop. Right? 1 greater or equal than 0, yeah. So then display 0, 1, and then decrement seconds. So seconds now is 0. So now it goes back. Is it 0 greater or equal than 0? Yep. It brings that up. And decrement seconds. Well, seconds is -1, right? This one. So it finds the curly bracket here, goes to the matching curly bracket. That's the question again. Is -1 greater or equal to 0? No. So exits the loop, right? So at this point I forgot this whole block of code and goes to here. Minutes decrement. Alright, now minutes is -1, right? And he goes to the next line. It says set seconds to 59. Goes down and oh, there's a curly bracket here. You didn't see the curly bracket when it was here. So this curly bracket is closed, and I gotta find the matching curly bracket. It's over here. Alright, minutes greater or equal than 0? No. Goes down. So it just prints that. So if I had asked you before, when this was 5 and 30, if I ask you how many iterations we have here, what will that be? So how many times this line of code executes this? The way we had it.
3 seconds? Or 5:30?
The original. The 530.
Would it be 330?
Yeah, it'll be 330, right? So it will be. So this is 60, right? So it's 5 times 60. So I will be asking you how many iterations you have. Questions? I think it's pretty straightforward. You guys took the recommended previous class? Time to move on, unless you have more questions. I mean, you can try this code at home. The best way to learn is you gotta practice. So, now I need to talk to you about constructors, which is what we talked about was the second. The first one is constructors, which we vaguely talk about them. So, when we're doing the scanner, we're doing the scanner, we know the new keyword allocates memory, right? Whatever is after the new, it's the size of memory it's going to allocate. So allocates whatever the size of a scanner is. And this looks like a method, right? That's parentheses. But it's the same as the class name, right? And that's why we call it a constructor, right? So, in the example, we did the person class or something like that, didn't we? So we have a class person, and that was you, and then we had it like this, but this one didn't take any parameters, right? But this still is the same, right? So therefore that's a constructor, right? This one has no parameters. This one does, right? So the one that doesn't have parameters call it a default constructor. But we really never made a method called that. Because we didn't make our own constructors, Java made one for us. I made the default one. It's the only one that makes it. The only constructor that Java makes if you don't specify any constructors, which we didn't. But today we're going to specify some constructors. So the idea of the constructor is we have the new keyword. The new keyword allocates memory. So I have this chunk of memory, and then after it fills out the blanks with the fields. But remember, a default constructor, every member or every instance variable, everything is set up to binary 0, right? Remember we did the person, we have the strings to be nulls because they were pointers, but the age I think we had was 0. And the gender, I don't know if we had a gender or not, would be false because it was a boolean. So now we're going to show you how to do constructors that don't have, that you can change the default values. You can make your own constructors. And to do that, we're going to simulate dice. Okay. The reason is it's like we were talking about the cards. When you start playing 21, you don't check if you had no card. If you're busted, if you have no cards yet, you need to at least pull one card or two cards actually. You guys played your blackjack? So there's some Indian casinos that have one deck blackjack. Oh, those are easy. You can win really easy. There was one that had, sorry. There's one that had three deck. And I'm like, oh, it must be easy. And then I'm like, wait a minute. The king of diamonds showed up already 4 times. There's no 3 decks there. So it's gonna throw out my count. You know, I go there, play $20, win 100, now I pay for dinner, and I'm gone. You will never become rich. All right. Let's import this library. Oh, this class. The library is utilities. Right. create this class, and I call it die. And this class die, how many sides does a die have?
6.
Only has 6, right? So I should have values between 1 and 6. So that's a whole number. So what type of variable will you use to represent the value of the die? You'll use an int, right? So you use an int. But because it's an instance field, I'm gonna make this private, right? You don't want people to like throw the dice and then flip them numbers you need and then win, right? It would be nice if you could do that in Vegas. And you can call it value or whatever. But an integer is a 32-bit number, so it can hold numbers from 2 to 32, right? 4 billion something. If you it's because it's signed, so half is negative, so negative 2 billion to positive 2 billion, whatever. But the die doesn't have that many sides, right? So we can make a static and if it's a constant, we use the word final. And I think I gave you extra credit if you did the static. I'm sorry, the constant. I'm gonna call this sides, and I'm gonna use capital letters. So if I have multiple dies and they're all random, right? How many copies of the random class do I need? Do I need a random class generator for each die, or can I have one for all of them? No. So if I have one for all of them, that means there's only one copy. Doesn't matter how many instances do I have. What type of variable is that? It's a static, right? So I can have a random number here, private. It's gonna be static. And the class is going to be random, that class. And I'm going to call this rand. My file instructor's name's rand. And he called me random. Anyways, so if I do this, how many bits did I allocate for this variable? By declaring this, how many bits did I allocate? Is this a primitive or a object? It's an object, right? So all objects, 64, right? They're all 64. So right now, it's a pointer that is pointing nowhere. I'll worry about that in a minute. Let's start with the easy part. Let's assume you already throw the die. You threw the die, and you want to see what value the die had. So I need an accessor to read the value. So the accessor will be public, right? Is it static or non-static? It's non-static because the value is non-static, right? And it's gonna return an int. And some books call it getter, so I call it get value. And it's just gonna return the value. So far, so good, right? That's very straightforward. You already talked about this. Now, will I have an accessor or a getter? Should I have a setter? Should I allow people to set the value of the die? No. What do you do with the die? You roll it. Exactly. So, I'm going to allow people to roll it, but I'm not going to allow them to force the value of the die. Therefore, there is no parameters. Well, the parameter list is empty. So once I'm in the roll, I gotta set the value of this thing. So assuming that this variable exists, the rand, right now it's pointing nowhere the way the code is. But let's pretend it exists right now in memory. We'll create it later, I'll show you. And we only create it once. So in here, I assume this one exists. So, supposedly, well, the computer doesn't know what random is. If I ask you, give me a random number, you will give me a number, but there's something not so random. In your subconscious, you probably have you went to Starbucks this morning and whatever the last number of your bill was, or today's date, or last numbers or last few numbers you saw, you're gonna base those. But the computer can see that. So the computer is gonna do this normal distribution. And the way it does it, it actually uses the current milliseconds divided by some prime number. And whatever that is, the whole number is what it returns. But it's an int, I have 2 to the 32 options, right? Normal distribution is like every number has equal chance. So this class rand, if I were to do rand and then press the dot, the IntelliSense will come. Well, IntelliSense is Microsoft, so Java, I don't know what they call it. Will show me the list of methods and properties, whatever, right? Just like the keyword, there's a next int. But this next int is gonna give you all 2 to the 32 options. But I don't want that. I only want 6 numbers, right? There's 2 ways to do it. I can divide this by a modular division. Remember what the modulus division is? What's the symbol? Percentage sign. So I can do this, right? Divided by sides. So let's say if it comes with the number 30, modular division 6, what will be the result? Modular division is the remainder. So if I got 30 divided by 6, what's my remainder? 0, right? So I'll return 0. Or I can do it, there's another flavor of the next int that takes a number which does exactly the same thing and make this modular division. So in other words, it'll give you numbers from 0 to 5. That's 6 numbers. 0 is a number. Like we did when we did 30 divided by modular division 6. Our remainder was 0. Does the die have a 0 value? So how do you fix that? Just add 1, right? Because the way it is, it's going to return any number from 0 to 5 inclusive, or 0 to 6 exclusive. So if I want to make it 1 to 6, I just add 1, right? And that's the value, right? So right now, you can roll a die and get the value. Oh, the code's good. So you compile it, try to run it, and it's going to give you null pointer exception. Because the RAN doesn't exist. The RAN is just pointing nowhere. So if you remember, I erased it, but when we had the constructor, when we had the constructor is simply a method, right? That is the same name of the class. So a constructor should be public. And it's just a method which is with the same name of the class. And do I have any parameters? No, I don't have any parameters. Now, this is my default constructor. Okay. I created my own constructor, so I don't want the constructor that Java does for me. If I make a constructor that takes parameter, it's just another method. It could have parameters like you did in the scanner. If I make a constructor that has parameters, then Java doesn't make any constructors for me if I make my own, if I make one. Therefore, there will be no default constructor. Because I made one, so Java doesn't make any for me. The only time it does it if I have made none. So if you try to do a scanner equals new scanner and you make a default one, it's going to give you an error. Because whoever made that class made it so that it has to take a parameter. All right. So, questions? So this first thing I want to do is I want to see if that pointer is pointing to somewhere or not. How will I write here to check if ran is empty or not?
Print the value of it.
Well, I don't want to print anything.
Oh.
Computer needs to know, not you. Or the computer knows. every time you check something, what's the keyword you use to check for something? Use an if then. Exactly. And then you're gonna see if the randomness exists or not, right? So, if random is equals what? Just null. If random is null, guess what? If it's null, then what you do? Just create it, right? Create things. You use the new keyword to instantiate a class. Okay, now my role will work because rand exists. Because this is the first thing is called, when a die is created, it calls a constructor, and then that's where I checked the value exists or not. So if I just create the die and read the value, if I call the get value, what will it return? The way the code reads, when an object is created, repeated, every instance variable, everything is set to what? Binary 0, right? So the way it is, if die is created, so it calls the constructor, allocates the memory, and then my constructor is where I check if this other class is instantiated or not. What's the value of value? What's the current value of value? If I do a system that I'll print out value, what will it print? What's the current? So if I print this, what will this green portion do? What will it print? But I just said earlier, what happens to all the instance?
Start at 0.
Everything is started at 0, right? So what's the current value of value? 0. Did I change the value there at some point? Then it stays at 0 until I tell it to do so. But that will be an invalid value, right? So what should I do when I create a die? Make sure it has a value between 1 and 6. Just roll it. If I just roll it, it'll have a value between 1 and 6. Whether you want to count it towards the your whatever game you're playing, it's up to you. Alright, so what I'd like you to do, we're just gonna finish in like 10 minutes, 15 minutes. What I'd like you to do is open your ID, create a project, make this class. And then we're gonna play with the class. Okay? Yeah.
We need a brackets after the if condition.
That's a good question. Do I need curly brackets here? That will work. How many lines of code do I need to execute if the if statement is true? Just one. If I only need one, I was waiting for somebody to ask me that. If I only need one line after, I don't need curly brackets. Same thing with the else. If the else only executes one line, I don't need this. Same thing with the while. If the while loop only needs one line, you don't need any curly brackets. All right.